So let's read it. Wants to fence in a rectangular plot of land adjacent to the north wall of his barn. Okay, so here's the wall of his barn, and he wants to fence in a rectangular plot of land adjacent. Okay, rectangular, x, x, y. No fencing is needed along the barn, and the fencing along the west side of the plot is shared with a neighbor who will split the cost of that portion of the fence. So this side is the west side, and it's split with a neighbor. So the cost of this will be only a half. 1/2 cost. Who will split? Okay. If the fencing costs $20 per linear foot, $20 per linear foot, okay, to install, and the farmer is not willing to spend more than $5,000, okay, find the dimensions for the plot that would enclose the most area. In other words, maximize area. Find the dimensions for the plot that would enclose the most area. Okay, so let's read this again before we embark on writing something. See how we get the function. Once we get the function, the rest is easy. A farmer wants to fence in a rectangular plot of land adjacent to the north wall of his barn. So he has a barn, and north of it, he has this rectangular area. So here it is. Here's the area. No fencing is needed along the barn. We got it. And the fencing along the west side of the plot is shared with a neighbor who will split the cost of the portion of the fence. Fine. If the fencing costs $20 per linear foot to install, and the farmer is not willing to spend more than $5,000, find the dimensions for the plot that would enclose the most area. Okay. So first of all, the area of this rectangular plot must be x times y. Now we do have some constraints here, and this is the function that we want to maximize. However, we see two variables. We see the width and the length. In this class, in Calculus 1, we only talk about functions of a single variable. So in other words, one of these two has to go away. I can't erase it, right? I have to create a relationship or determine a relationship between the two. So the problem here is that the neighbor, for the neighbor, is less than or equal to 5,000. So we have to pick up the rest of the cost. What will be the cost? The total cost for the fence will be x plus y plus x. So I said half a cost, but it's not really half the cost. It's shared. We don't know if it's going to be a half. We don't know that. So I have to correct that, because initially when I read the first time, I said, oh, okay, so they're making that area, that part 50-50, but no. So he's not willing to pay more than $5,000 maximum. Okay, so what is the cost, total cost? So it's x plus y multiplied by 20. So 2x plus y multiplied by 20 per linear foot. Now, we know that from this total cost, the 5,000 is the maximum that the neighbor will pay. So then I will say that the total cost for us, if we are in this situation, or the farmer, the total cost for the farmer will be 2x plus y times 20 minus 5,000. Okay, so at this point, we have to connect the area to this x and y somehow. Any suggestions? Because we are trying to maximize the area, having these restrictions. Any ideas?
Can you ask that question again?
Yes. So the question, the problem is asking us to maximize the area. In other words, find x and find y that will maximize the area. Knowing that the cost of the fence per linear foot is 20, and we're going to pay for the whole thing minus the 5,000 that the neighbor is willing to pay. I just want to read that part one more time. We split the cost. Okay, for me, splitting the cost meant one half.
But isn't the 5,000 from the farmer, not from the neighbor?
Yes, from the neighbor. No, let's read it again. Maybe I missed something.
Because it says the farmer is not. I thought the total wasn't supposed to go over 5,000, not the shared amount.
Yes, actually, you're right. So then obviously I have to read it again. A farmer wants to fence in a rectangular plot of land adjacent to, okay, no fencing, that's clear, and the fencing along the west side of the plot is shared with a neighbor who will split the cost of that portion of that fence. If the fencing, okay, to install, and the farmer, you're right, is not willing to spend more than 5,000. Okay, so does that mean then that I was right initially? Will split the cost, which means splitting the cost means half and half. Am I correct?
Half and half
of that.
Really, a fourth of x.
No. We know. So we don't have a fourth because there is no. So this is no y. There is no fence here. So
right, but there's x and x, but the neighbor is only on one x. So half of that.
Exactly. So we have half of x plus y. Absolutely, I completely agree. So and that has to be less than or equal to 5,000. Yeah. Excellent. So I think I'm going to just remove this instead of. Thank you for pointing that out. So this is my page 5. So I have a equals x times y, and of course we have single variable calculus. So we have to get rid of one of these functions, and then one of these variables, and then I will say it's a of x or a of y. It doesn't matter which one. So indeed, he's not willing to, so the maximum cost, that was correct, is less than or equal to 5,000 for the farmer. And what is the maximum cost for him? So it's 1/2 x plus y multiplied by 20 per linear foot. This has to be less than or equal to 5,000. Any questions so far? So it's not the neighbor, but it's the farmer. Okay. So we have 1/2 plus x, which is 3/2 x, plus y multiplied by 20 has to be less than or equal to 5,000. When I distribute 20, I have 30x plus 20y equals 5,000. So that is the maximum. So it is less than or equal to, but I have from here, I have to solve either for x or for y. Why? Because one of them has to be replaced in here, so I can get a function in x alone or in y alone. It doesn't matter. So yes, of course, I can simplify by 10. So I have 3x plus 2y equals 500. So which one would you like to solve for? Would you like to solve for y, or would you like to solve for x? Once we have either x or y, we plug it in, and we have the function that we need to work with. If you decide to solve for y, it's easier. Not easier, but we're just going to keep a function of x. But it doesn't matter, really. Which one?
I prefer to solve for y.
Okay, then. So if we solve for y, I have to move 3x to the other side. And I have to divide by 2. So y equals negative 3/2 x plus 250. Awesome. So now the function a equals x times y becomes a of x, becomes a function of x, because I need to distribute x in here. So negative 3/2 x squared plus 250x. And this is what I need to find the max or min for. Of course, we are shooting for a max. It's a quadratic function. It has a negative leading coefficient. I still have to prove using calculus that what we get is a maximum. But let's analyze the steps that we went through and see if we have questions, and then we'll finish it up. Any questions on any of these steps? Any questions? Anyone, please? Any questions? Any questions?
No.
Okay, then. What do I have to find in order to determine max min?
A prime.
A prime of x equals negative 3x plus 250. Undefined does not exist here, so maybe this is not very good. So a prime of x equals 0 will be negative 3x equals negative 250, or x equals 250 divided by 3. So therefore, a prime of x, a of x, this is mandatory to show using calculus that I know how to find critical numbers and study the sign of the derivative in order to find the max or the min. So if in this function I plug in 0, this is positive. And if I plug in 1,000, this is basically negative. So this is very clear. And this is typical for a maximum. What is the maximum? I don't know. It's a of 250 over 3. And I will put it in the graphing calculator. Where is my function? Or just plug it in. It's just one value. If you want to put in y equals, you put in the y equals, or negative 1.5. And in parentheses, I have 250 over 3. And I have to square that. And then plus 250 times 250 over 3. So it's squared. divided by 3. So I got, even if they're not asking us, I still would like to see 10,416.67. And this is the area in square feet, of course. Any questions? Any questions? Very good. Let's continue. Where are you guys? I see you. Okay. Good. A rectangular storage container without a lid is to have a volume of such and such. Okay. So 4, 5, 6. Okay, we're on 6. So let's look at 21. A rectangular storage container without a lid is to have a volume, so the volume equals 10 cubic meters. The length of its base is twice the width. So here is the rectangular storage container. And it says the length is twice the width. If this is the width, x, the length is twice x. We read again. Okay. Material for the base costs $10 per square meter. Okay. Material for the sides costs $6 per square meter. Okay. Find the cost of materials for the least expensive such container. What does that mean? Least expensive such container. What are we asked to find? So the dimensions, so there is a height, of course. So they're asking us to find x, 2x, and the height for the least expensive container. What are we asked to find? Optimization.
Minimum
Yes, minimum what?
cost.
Yes, minimum cost. Very good, awesome. That's what we are asked to find.